Picture this: a forest where the trees don't grow straight toward the sky like they should. Instead, their trunks twist and coil, bending into strange, almost unnatural shapes, as if they've been frozen mid-dance. This is the enigma of the dancing forests, a place where nature defies its own rules, leaving behind a landscape that feels more like a scene from a fairy tale than reality. Stretching across remote corners of the world, from the Kaliningrad region in Russia to the highlands of Poland, these twisted groves have baffled scientists, historians, and locals for centuries. What force could possibly bend entire forests into such eerie, mesmerizing forms? Some whisper of ancient curses, others point to unseen energies lurking beneath the soil, and a few dare to suggest something even more extraordinary. But the truth is stranger than fiction. The mystery of the dancing forests isn't just about the trees themselves. It's about the stories woven into their gnarled bark, tales of lost civilizations, secret experiments, and whispers of the supernatural. Locals have long regarded these woods as sacred or haunted, avoiding them after dark, while researchers have scoured the soil for clues, uncovering everything from odd magnetic fields to traces of forgotten rituals. But despite decades of study, no single theory fully explains why these trees grow in such bizarre, almost deliberate patterns. Could it be the work of underground gases warping their roots? The lingering effects of long-vanished glaciers? Or is there something far older, far weirder, hidden beneath the surface? This is where our journey begins. Because the dancing forests aren't just a curiosity, they're a puzzle waiting to be solved, a riddle written in bark and branches. And as we peel back the layers of myth and science, we'll uncover a story that stretches from the depths of prehistory to the cutting edge of modern research. Along the way, we'll meet the people who have devoted their lives to unraveling this mystery, explore the most compelling theories, and maybe, just maybe, get one step closer to understanding what really happened in these haunted woods. So if you're ready to step into the unknown, to walk among trees that seem to whisper secrets of the past, then let's begin. The forest is waiting. The most famous of these twisted woodlands lies in Russia's Curonian Spit, a narrow stretch of land nestled between the Baltic Sea and the Curonian Lagoon. Here in the Kaliningrad region, the dancing forest, or Tanzender Wald as locals sometimes call it, draws visitors from around the world. Its pine trees spiral and loop in impossible contortions, some forming perfect rings, others bending sharply at the base before jutting sideways like frozen waves. But this isn't the only place where trees seem to defy gravity. Similar groves have been spotted in Poland's Gryfino forest, where the so-called crooked forest features 400 pines that all curve 90 degrees at their base before shooting upward in eerie unison. Even farther afield, reports trickle in from places like Kazakhstan and North America, where isolated patches of woodland exhibit the same uncanny warping. These forests didn't emerge overnight. The earliest documented accounts date back centuries, with Baltic fishermen and Prussian villagers passing down warnings about the bewitched woods. By the 19th century, European naturalists began cataloging the anomalies, puzzled by how entire stands of trees could grow in such synchronized distortion. But it wasn't until the mid-20th century that scientists took serious notice. After World War II, Soviet researchers studying the Curonian Spit stumbled upon the dancing forest and immediately recognized its strangeness. Unlike storm-damaged trees which twist randomly, these formations followed bizarrely uniform patterns, almost as if guided by an invisible hand. Locals, meanwhile, clung to older explanations. Some spoke of a legendary sorceress who'd cursed the land, while others blamed restless spirits trapped beneath the roots. What makes these forests so captivating isn't just their appearance, it's the way they blur the line between nature and myth. Scientists arrive with measuring tapes and soil samples, seeking rational answers, while storytellers weave tales of cosmic energy vortices or buried artifacts radiating strange forces. Even today, the debate rages on. Forestry experts point to environmental factors like unstable sand dunes or invasive moth larvae altering growth patterns, while fringe theorists suggest everything from gravitational anomalies to clandestine Nazi experiments. Yet despite decades of study, no single theory has fully unraveled the mystery. The dancing forests remain a living paradox where science and legend collide beneath a canopy of crooked branches. And as more of these groves are discovered, the question only grows louder. What other secrets might these silent, twisting sentinels be hiding? Walk through the dancing forests at dusk, and you might understand why generations of locals speak in hushed tones about these places. In the Kaliningrad region, villagers recount nights when the twisted pines creak and groan as if alive, their contorted branches swaying even when no wind blows. Fishermen along the Curonian lagoon tell of flickering lights deep in the woods, vanishing the moment someone approaches, while others swear they've glimpsed shadowy figures weaving between the trunks, always just out of sight. The oldest stories speak of a witch buried beneath the roots, her restless spirit bending the trees to her will, cursing anyone who disturbs her slumber. Over in Poland's Crooked Forest, the legends take an even darker turn. Farmers from Gryfino whisper that the 400 mysteriously curved pines mark the site of a forgotten mass grave, their unnatural shapes echoing the final convulsions of the buried. Some claim the trees themselves are alive in ways science can't explain, that on certain moonless nights the entire forest shifts like a living thing, trunks twisting further as if pulled by invisible hands. One elderly woodsman insists he once saw a sapling coil around itself like a snake, completing its strange spiral in mere minutes before freezing back into place. But it's not just folklore. Modern visitors, hikers, photographers, even skeptics have returned with eerily similar accounts. A German geologist camping near the Curonian Spit in 2012 reported waking to a sound like hundreds of fingers drumming on bark, only to find the forest utterly still. A group of students filming the Crooked Forest in 2018 accidentally captured a low, humming vibration on their audio equipment, a frequency with no identifiable source. And every few years, another tourist vanishes near these groves, their belongings found neatly arranged at the base of a twisted tree as if they simply stepped into the bark. Scientists dismiss most of these stories as superstition or misperception, of course. They'll tell you the sounds are just shifting sediment under the dunes, the light swamp gas or bioluminescent fungi. But listen closely to those who have lived near these forests for generations, and you'll notice something unsettling. Their stories haven't changed in centuries. The details match, from the creaking trunks to the figures in the mist, as if something in these woods is repeating itself, waiting to be understood. Or perhaps warning us to stay away. Scientists studying the dancing forests often start with the wind, because if you've ever seen a tree clinging to a cliffside or bending along a stormy coastline, you know nature has a way of shaping life through sheer force. In places like the Curonian Spit, where the Baltic Sea clashes with shifting sand dunes, ferocious winds whip across the landscape with enough power to sculpt entire dunes and possibly trees. The theory goes that relentless gusts combined with the unstable, sandy soil could have caused young saplings to tilt and twist as they struggled to anchor themselves. Over decades, these subtle bends would harden into permanent curves, creating the forest's signature spirals. But there's a catch. While wind can explain isolated cases of leaning trees, it doesn't fully account for the synchronized patterns seen in places like Poland's Crooked Forest, where hundreds of pines curve at the same precise angle, all within a small, concentrated area. If wind were the sole culprit, you'd expect randomness, some trees bending left, others right, some hardly affected at all. Instead, these groves exhibit an eerie uniformity, as if obeying some unseen blueprint. This is where soil composition enters the picture. beneath the dancing forests, the earth tells its own story. In Kaliningrad, the ground is laced with layers of unstable sand, constantly shifting under the weight of dunes that migrate over time. Researchers speculate that as these sands move, they could destabilize root systems, causing trees to tilt gradually as their footing erodes. Even more intriguing are reports of pockets of methane or other gases trapped beneath the surface, chemical imbalances that might stunt growth on one side of a tree, forcing it to contort as it reaches for sunlight. Then there's the case of parasitic influence. Some botanists point to microscopic pests like nematodes or fungal infections that attack a tree's growth cells, warping its development from within. Imagine a tiny organism burrowing into the base of a sapling, disrupting its ability to grow straight, leaving behind those signature 90-degree bends. It's a compelling idea, except again for the scale. Natural infestations rarely affect every tree in a grove so uniformly. What ties these theories together is time. The dancing forests didn't twist overnight. Their shapes were forged over generations through countless storms, shifting soils, and biological pressures. Yet even the most rigorous scientific explanations leave gaps. Why these forests and not others under similar conditions? Why do the curves seem almost intentional, as if guided by some invisible hand? For every answer, there's a lingering question, a whisper of something beyond the measurable world, and that's what keeps researchers and storytellers coming back. Among the most captivating and hotly debated explanations for the dancing forests is the idea that hidden magnetic forces beneath the soil might be pulling these trees into their strange shapes. Picture Earth's magnetic field like an invisible river flowing around the planet in predictable patterns. But sometimes that river hits snags, localized distortions caused by underground mineral deposits, geological faults, or even ancient volcanic activity. In places like Russia's Kola Peninsula or Sweden's Kiruna mines, researchers have documented trees growing stunted or twisted near areas with intense magnetic anomalies. Could the same forces be at work in the dancing forests? The theory gained traction in the 1970s when Soviet geologists surveying the Curonian Spit noticed compass needles wobbling erratically near the most contorted trees. Later measurements revealed patches of unusually strong magnetism in the soil, with some spots registering nearly 3 times the normal background levels. Experiments followed. Botanists planted pine saplings in magnetically disturbed zones and watched as they developed slight curves compared to control groups. But skeptics were quick to point out gaps. While magnetism might explain minor bending, it doesn't fully account for the dramatic spirals or the eerie uniformity seen in places like Poland's Crooked Forest, where every tree bends northward at the exact same height. Dig deeper, though, and the plot thickens. Some researchers speculate these forests might sit atop intersections of geological faults, where subterranean stress creates weak electromagnetic currents. In 2005, a team from the University of Gdansk mapped the Crooked Forest's magnetic field and found faint but detectable pulses radiating from the ground, rhythmic fluctuations that matched the tree's growth patterns almost perfectly. Even stranger, similar pulses have been recorded in other twisted forests worldwide, from Kazakhstan's Altan Imel National Park to a lesser-known grove in Oregon's Willamette Valley. Yet for every study supporting the magnetic hypothesis, another raises doubts. Critics argue that Earth's magnetic fields simply aren't strong enough to warp something as rigid as a growing pine. Others note that many magnetic hotspots exist where trees grow perfectly straight. Then there's the mystery of timing. Historical records suggest some dancing forests began twisting centuries ago, long before modern tools could detect subtle magnetic shifts. Could these groves be reacting to a deeper, older force, one we've yet to measure? One thing's certain: whether the cause is magnetism, geology, or something beyond our current science, the dancing forests challenge our understanding of nature's rules. And perhaps that's the real allure, not just the answers we might find, but the questions that keep us searching. Some of the wildest theories about the dancing forests come straight from the fringes of science, where gravity itself, that fundamental force we take for granted, might not behave the way textbooks claim. Imagine pockets of land where the very pull of the earth is slightly off-kilter, where unseen forces tug at roots and trunks just enough to steer growth into those uncanny spirals. It sounds like science fiction, but a handful of researchers argue there could be geological quirks capable of creating micro-variations in gravity strong enough to warp living things over time. The concept stems from rare but documented phenomena like gravity anomalies, localized zones where gravitational pull measures stronger or weaker than the surrounding area. These usually occur near dense mineral deposits or deep geological faults where the Earth's mass isn't uniformly distributed. In places like Canada's Hudson Bay or India's Brahmaputra Valley, satellites have detected gravitational dips so pronounced they've subtly altered sea levels. Now apply that same logic to a forest. If certain patches of ground exerted even a fractionally different pull, could it nudge saplings into bending toward or away from the anomaly as they grow? Proponents of this theory point to the work of independent researchers like Dr. Anton Fedorov, who in the early 2000s mapped gravitational variations across the Curonian Spit using ultra-sensitive gravimeters. His team claimed to find subtle discrepancies, areas where gravity measured 0.001% weaker, that loosely correlated with the forest's most twisted sections. Skeptics dismissed the findings as statistical noise, but the idea gained traction in alternative science circles. Then came the clincher. In 2016, a Polish geophysics team studying the Crooked Forest stumbled upon an oddity. Their gravity maps revealed an elongated, crescent-shaped zone beneath the trees where readings dipped ever so slightly, matching the curve of the pines almost perfectly. Critics counter that Earth's gravity just doesn't work that way. It's too consistent on small scales to explain dramatic tree warping. But what if it's not gravity alone? Some theorists propose these forests sit atop hidden geological formations, collapsed caverns, ancient meteorite impacts, or even geological vortices, where subterranean fluid dynamics create minute but persistent directional forces. In the Ural Mountains, similar twisted forests grow near known fault lines where tectonic stress generates weak electromagnetic fields. Could these forces combine gravity, electromagnetism, and subterranean movement to nudge trees into spirals over decades? Then there's the most controversial twist, the idea that these forests might be natural laboratories for exotic physics. A fringe paper published in 2019 speculated about quantum-scale gravitational fluctuations, hypothetical ripples in spacetime that, under extreme conditions, might locally alter how mass interacts. The authors noted that several dancing forests coincide with regions of historic seismic unrest, where deep Earth processes could theoretically generate such effects. Mainstream physicists scoffed, but the suggestion lingers. If gravity isn't perfectly uniform across the planet, we're better to look for proof than a grove of trees frozen in unnatural curves. Of course, without irrefutable evidence, these ideas remain in speculative territory. Yet the sheer persistence of gravitational theories speaks to a deeper truth about the dancing forests. They challenge our assumptions about how the natural world operates. Whether through hidden mineral deposits, subterranean forces, or something far stranger, these twisted groves remind us that Earth still holds mysteries no textbook can yet explain. And perhaps that's why, for every scientist dismissing gravity distortions as fantasy, another quietly wonders, if the trees are bending, what else might be bending with them? Could the dancing forests be something more than a natural oddity, something not of this world? Among the countless explanations for these twisted groves, few spark as much debate as the claims linking them to extraterrestrial activity. Picture this: remote woodlands already shrouded in eerie silence, where the trees themselves seem sculpted by forces beyond human understanding. It's no surprise that UFO enthusiasts and conspiracy theorists have latched onto these places as potential sites of otherworldly interference. Stories of strange lights hovering above the treetops, of saplings bending overnight as if manipulated by invisible hands. These accounts weave a narrative that blurs the line between folklore and fringe science. Take the Curonian Spitz dancing forest, where locals have reported glowing orbs drifting between the twisted pines since at least the 1950s. Soviet military logs from the Cold War mention unexplained radar blips over the area, dismissed at the time as equipment malfunctions. But in 2003, a group of German tourists filming the forest at dawn captured a cluster of bright, disc-shaped objects vanishing into the tree line, footage that, while grainy, fueled speculation for years. Even more unsettling are the whispers from Poland's Crooked Forest, where farmers in the 1930s allegedly found patches of scorched earth and metallic fragments nestled in the roots of the warped trees. Some insist these were remnants of a crashed craft, its energy field responsible for distorting the surrounding pines. Then there's the theory of deliberate experimentation. Some ufologists argue that the forest's uniformity, hundreds of trees bending in perfect synchrony, suggests an intelligence behind their shaping. Could advanced beings have tampered with the growth patterns, either as a test of bioengineering or as a cryptic message etched into the landscape? A declassified CIA document from 1978 references an anonymous informant describing vegetal manipulation by non-human entities, though skeptics dismiss it as Cold War paranoia. Still, the idea persists, especially in regions where multiple dancing forests cluster near historic UFO hotspots, like Kazakhstan's Turgai Depression or Oregon's Mount Hood. Of course, mainstream science scoffs at these claims. Biologists point out that trees don't need alien intervention to grow. Strangely, natural phenomena like phototropism or fungal infections can produce similar effects. Yet the persistence of these stories raises an intriguing question. Why do so many accounts of UFO activity overlap with these specific forests? Whether it's misidentified aircraft, atmospheric phenomena, or something far stranger, the connection lingers in the cultural imagination. And perhaps that's the real power of the dancing forests. They don't just bend trees. They bend our perception of what's possible, leaving room for wonder in a world that often insists on tidy explanations. One thing's certain, until someone proves definitively what warped these groves, the theories from the grounded to the galactic will keep twisting as wildly as the trees themselves. And maybe that's how it should be. Some mysteries aren't meant to be solved. They're meant to keep us looking up, questioning, and marveling at the oddness of our own planet. After all, if the truth were simple, would these forests dance so vividly in our imaginations? Beneath the twisted branches of the dancing forests, another layer of mystery lurks, one tied not to folklore or natural forces, but to the shadowy world of Cold War experimentation. Whispers have long circulated that these groves were more than just curiosities. They might have been testing grounds for secret military projects, places where science veered into the unnerving unknown. From the 1950s onward, both Soviet and NATO scientists were desperate to gain any advantage in their high-stakes arms race, and some speculate that isolated forests like Kaliningrad's or Poland's Crooked Forest provided the perfect cover for clandestine work. Declassified documents from former Eastern Bloc archives hint at bizarre experiments involving radiation and plant growth. In the late 1960s, Soviet biophysicists reportedly exposed young trees to controlled doses of gamma rays, observing how ionizing energy could alter cellular development. One memo describes pine saplings near a secret facility in the Baltics bending at precise angles after exposure, an eerie parallel to the dancing forest's unnatural curves. Even more unsettling are accounts from Polish military records mentioning Project Chaos U, shrub, a purported Cold War initiative testing biological agents on vegetation. Witnesses described patches of forest where trees grew in grotesque spirals overnight, coinciding with reports of masked figures collecting soil samples under cover of darkness. But the most chilling theory involves not radiation but sound. During the Cold War, both superpowers explored infrasound, low-frequency vibrations inaudible to humans but capable of inducing physical effects. Declassified U.S. Army papers from 1972 reference tests using infrasonic emitters to direct vegetative growth patterns, while Soviet scientists allegedly experimented with acoustic weapons near the Curonian Spit. Could these covert trials have left behind a legacy of warped trees, their growth permanently scrambled by invisible vibrations? Skeptics argue that if military experiments were responsible, we'd see more consistent evidence, declassified blueprints, first-hand testimonies, or radiation traces in the soil. Yet fragments of the puzzle persist. In 2009, a team scanning Poland's Crooked Forest with ground-penetrating radar discovered buried metal objects arranged in a grid pattern too orderly to be natural, too old to be recent debris. Then there's the account of a retired East German engineer who in 1991 confessed to working on a project called Waldformung, forest shaping, claiming teams used electromagnetic fields to steer tree growth for camouflage purposes. Whether fact or conspiracy, these stories tap into a deeper unease. The dancing forests don't just defy nature, they feel manipulated, as if something beyond wind or soil reached in and twisted them deliberately. And in the context of the Cold War's unchecked scientific ambition, that something might not have been supernatural at all. It might have been us. Long before scientists puzzled over the dancing forests, the people who lived near them already had answers, but these weren't explanations of soil or magnetism. They were stories of gods and magic, of rituals so old their meanings have faded into the wind. Across Europe, whispers persist that these twisted groves weren't shaped by nature at all, but by the hands or curses of ancient pagan cults. Imagine a time when every tree, spring, and hilltop pulsed with sacred energy, where ceremonies could bend the very fabric of the living world. That's the lens through which our ancestors saw these forests. Take the Curonian Spit's dancing forest. Baltic folklore tells of a powerful priestess of Perkunas, the thunder god, who planted a sacred grove here centuries ago. According to legend, she wove spells into the saplings, binding them to grow in spirals as a gateway between realms. Anyone who disturbed the grove, it was said, would find their own limbs twisting in agony by dawn. Similar tales clung to Poland's Crooked Forest, where medieval chronicles describe a pagan rite called the bending, a ritual where young trees were deliberately warped to trap evil spirits within their wood. Villagers avoided these groves for generations, fearing the trapped entities might still writhe inside the contorted trunks. The deeper you dig, the more patterns emerge. In Germany's Harz Mountains, a lesser-known twisted forest grows near the remnants of a prehistoric stone circle. Local lore claims the trees began bending the night the last pagan priest was executed there, as if the land itself recoiled in grief. Further east, near Russia's Lake Ladoga, archaeologists found carved idols buried at the base of a spiraling pine grove, offerings to a forgotten tree deity mentioned only in fragmentary scrolls. Even the Sami people of Scandinavia have oral traditions about singing forests, where shamans once shaped trees into rings to amplify their chants to the spirits. Could these stories hold fragments of truth? Modern researchers have noted eerie consistencies. Many dancing forests align with historic pagan sites, often atop ley lines or near ancient burial mounds. Dendrochronology, the study of tree rings, reveals that some groves began warping during periods of violent religious upheaval, like the Christianization of Europe in the 10th century. Was this nature's coincidence or something more? Ethnobotanists point to indigenous practices worldwide where trees were deliberately bent into markers or living altars. The New Chonolth people of Canada, for instance, trained saplings into arches to denote sacred spaces. If similar techniques existed in Europe, might their purpose have been lost to time? Then there's the darker thread, the idea of curses. In Latvia, folk songs describe witches knotting trees to hex enemies, their malice seeping into the roots. A 17th century Lithuanian text warns of forests where the devil combs the pines into coils, a metaphor some historians interpret as coded references to outlawed pagan magic. Even the timing fits. Many dancing forests show accelerated twisting during the witch trials of the 16th and 17th centuries, as if the land absorbed the terror of that era. Of course, proving a supernatural link is impossible, but that's not the point. These stories, whether metaphor or memory, reveal how humans have always sought meaning in nature's strangeness. When we stand beneath those gnarled branches today, we're not just seeing trees, we're glimpsing the shadow of a world where every hill had a spirit, every grove a guardian, where the line between the earthly and the divine was as twisted as the pines themselves. And perhaps that's why the dancing forests still unsettle us. They're relics of a time when the world felt alive in ways we've forgotten, and the trees might just remember. Poland's crooked forest isn't the only place where trees seem to defy the laws of nature. Across the globe, pockets of woodland echo these same eerie distortions, each with its own set of mysteries. In Kazakhstan's Altai-Nemel National Park, a grove of ash trees twists unnaturally, their trunks spiraling like corkscrews despite growing in open, wind-sheltered plains. Over in Japan, the Yoro Ravine's dragon spruce trees coil skyward as if frozen mid-dance, while in New Zealand's Catlins Forest, an entire stand of yellow-leafed kamahi trees bends sharply at identical angles despite no recorded storms or landslides to explain it. These scattered groves raise a haunting question. Are they all products of the same hidden forces, or does each forest twist for its own peculiar reason? Take Poland's crooked forest, where 400 pines curve sharply at their base before shooting straight upward, a phenomenon locals claim began in the 1930s. Unlike the Curonian Spitz dancing forest, where trees spiral randomly, every trunk here bends uniformly northward, as if pulled by some unseen magnet. Researchers have floated theories ranging from deliberate human shaping, possibly to create naturally curved timber for furniture or shipbuilding, to localized gravitational quirks. Yet neither explanation fully accounts for the precision of the curves or why similar groves worldwide lack this uniformity. Meanwhile, Kazakhstan's twisted ash trees grow in soil laced with selenium, a mineral known to stunt plant growth, leading some scientists to speculate that toxic subsoil could warp their development. But if that's the case, why don't neighboring trees show the same distortions? Then there's Japan's Yoro Ravine, where the twisted spruces grow along a geological fault line. Seismologists note that the area experiences subtle, constant tremors, microquakes too faint for humans to feel, but possibly strong enough to stress growing trees into spirals over decades. This theory gains traction when you compare it to Oregon's Devil's Staircase Forest, where Douglas firs corkscrew atop a dormant volcanic fissure. Yet again, inconsistencies emerge. New Zealand's crooked kamahi trees, for instance, thrive far from fault lines, their bends attributed instead to a rare fungal infection that alters wood density unevenly. But if fungi are to blame, why do only select species succumb while others stand straight? What becomes clear is that no single explanation fits every twisted forest. Some, like Poland's, hint at human interference. Others, like Kazakhstan's, point to toxic soils or pathogens. A few, like Japan's, align with geological activity. And then there are the outliers groves where even the wildest theories fall short. In the highlands of Ecuador, the enchanted forest of Sigzig contains trees that twist in opposing directions within the same patch, defying all known patterns of wind or erosion. Locals say the grove sits atop a network of underground quartz caves, which New Age theorists claim amplify Earth energies. Scientists predictably scoff, but when pressed, even they admit quartz can generate weak piezoelectric charges under pressure. Could minute electrical currents subtly redirect growth? The debate rages on. What ties these forests together isn't a shared cause, but a shared enigma. Each grove stands as a testament to nature's capacity for contradiction, a reminder that even in our age of satellites and sensors, the Earth still keeps secrets. Whether through human hands, hidden toxins, or forces we've yet to name, these trees whisper the same unsettling truth. Sometimes nature's most beautiful patterns are the ones we can't explain. Deep in the cells of every tree, hidden from sight, lies a delicate dance of chemicals guiding every bend and curve, a phenomenon scientists are only beginning to decode. At the heart of the mystery are plant hormones, tiny molecules with outsized influence, and none is more intriguing than auxin. Picture auxin as the tree's internal architect, a chemical whisperer that tells cells when to grow, how much to stretch, and in which direction. Normally, auxin distributes evenly, ensuring trunks rise straight toward sunlight. But in the dancing forests, something disrupts this balance. Researchers have found patches of twisted pines where auxin concentrations spike unpredictably, pooling on one side of the trunk like an invisible hand pressing the tree off course. These hormonal imbalances don't happen randomly. Studies suggest certain environmental stressors, extreme temperature swings, unusual soil chemistry, even prolonged droughts can trigger auxin to misbehave. In the Crooked Forest, soil samples revealed traces of heavy metals like cadmium, known to interfere with hormone pathways. When scientists replicated these conditions in lab-grown saplings, they watched as the plants developed those same signature 90-degree bends. But here's the twist: not every tree exposed to these stressors warps. That's where genetics enters the picture. Hidden in the DNA of these trees might be silent mutations, tiny genetic quirks that make certain pines hypersensitive to auxin disruptions. In 2019, a team from the University of Warsaw isolated a gene variant in the Crooked Forest pines nicknamed Twist1, which appears to alter how cells respond to hormonal signals. Trees carrying this variant, when stressed, don't just bend, they spiral, as if their growth instructions have been scrambled. Yet even this discovery raises new questions. Why would such a mutation persist in these specific groves and nowhere else? Some biologists propose it's an evolutionary fluke, a genetic roll of the dice frozen in time. Others wonder if human intervention centuries ago, like selective breeding for shipbuilding or furniture, accidentally locked these traits into the population. The story grows stranger when you compare forests across continents. Kazakhstan's twisted ashes, for instance, show no trace of the Twist1 variant. Instead, their warping has been linked to a fungal symbiosis that hijacks auxin production. Meanwhile, in Japan's Yoro ravine, researchers found trees with perfectly normal hormone levels yet wildly contorted trunks, hinting at epigenetic factors, chemical switches on DNA activated by environmental cues without altering the genetic code itself. These contradictions suggest there's no universal explanation, only a web of biological possibilities. What emerges is a portrait of nature's complexity, where hormones, genes, and environment collide in unpredictable ways. The dancing forests might be nature's experiments, laboratories where trees explore the outer edges of growth. And as scientists peel back these layers, they're uncovering something profound, that even in stillness, these trees are moving, shaped by forces seen and unseen, writing their secrets in rings and bark. Standing in the dancing forests, you might notice something unsettling. These twisted trees often grow in pockets of land where the wind behaves differently. Not the occasional gust, but relentless, channeled winds that seem to carve their way through the groves like invisible rivers. Scientists studying microclimates, the small-scale weather patterns unique to a specific area, have found that many of these forests sit in natural wind tunnels, where geography funnels air currents into concentrated, repetitive flows. The Curonian Spit, for instance, acts like a narrow corridor between the Baltic Sea and the lagoon. compressing sea breezes into concentrated streams that batter the trees from one consistent direction. Over decades, these forces could gradually push saplings off course, their growth adapting to the constant pressure like a boxer leaning into a punch. But wind alone doesn't explain everything. Some of the most twisted groves thrive in places with bizarre temperature inversions, layers of air where cold gets trapped beneath warm, creating stagnant, almost viscous conditions near the ground. In Poland's Crooked Forest, meteorologists recorded pockets where temperatures at root level dip dramatically compared to the surrounding area, creating a sort of cold sink. Trees growing here might experience slowed growth on one side, where chilled sap flows sluggishly, while the warmer side stretches upward, resulting in those signature bends. It's a phenomenon seen in high-altitude krummholz trees, where icy winds stunt growth on the windward side, sculpting trunks into gnarled shapes. Then there's the moisture factor. Certain dancing forests cluster near wetlands or underground springs, where waterlogged soil creates an unstable foundation. Combine that with wind, and you have a recipe for gradual tilting, roots struggling to anchor in the soft earth while the canopy gets persistently pushed. Satellite thermal maps of Kazakhstan's Altai-Nemel twisted ashes show higher soil moisture levels exactly where the trees spiral most severely, suggesting waterlogged roots might amplify the effects of other stressors. Yet even these microclimate theories hit snags. Why do some trees in the same grove, exposed to identical winds and temperatures, grow perfectly straight? Why do the bends often start at the same height, as if the trees agreed on an unspoken rule? Some researchers speculate these forests might sit at the crossroads of competing microclimates where sea air clashes with continental winds, or where elevation shifts create pockets of turbulence. In these zones, trees could be caught in a tug of war between forces, their growth records etched into rings like a diary of environmental conflict. Ultimately, the microclimate angle offers compelling clues but no definitive answers. It's a reminder that nature rarely works in isolation. Wind, temperature, moisture, they're threads in a larger tapestry, and in the dancing forests they weave patterns we're still learning to read. Every twisted trunk is a snapshot of 100 silent battles between tree and sky, root and soil, and perhaps that's the real mystery, not just why these trees bend, but how they endure. Could the bizarre shapes of the dancing forests be the work of human hands rather than natural forces? This idea might sound far-fetched at first, but history shows us that people have shaped trees for practical and symbolic purposes for millennia. From the living root bridges of India to the pleached alleyways of medieval Europe, humans have long manipulated tree growth with astonishing precision. When you look at Poland's Crooked Forest, where 400 pines bend in flawless unison, it's hard not to wonder, was this orchestrated by someone centuries ago? One compelling theory suggests these trees were intentionally trained for shipbuilding. Historical records from Northern Europe describe a technique where young saplings were weighted or tied to grow into curved shapes perfect for crafting hull ribs and keels. A single mature tree could yield multiple naturally arched beams, stronger than anything cut and bent by hand. Some researchers point to the timing. The Crooked Forest trees likely began warping in the 1930s, when wooden ship components were still in demand. If a timber company planted and shaped these pines, they might have abandoned the project when steel ships replaced wooden ones, leaving behind a forest frozen mid-sculpture. But not all human influence was practical. Certain groves aligned too perfectly with ancient cultural sites to ignore. In Germany's Spreewald, twisted oaks mark the boundaries of old Slavic ceremonial grounds, their bends possibly shaped to denote sacred spaces. Similarly, Baltic pagans were known to sign trees by carving symbols into bark, which could alter growth over generations. Folklorists in Latvia have documented birch trees deliberately knotted into loops, living wish markers where passing travelers added bends as part of forgotten rituals. Could the dancing forests be vast, overgrown versions of these arboreal artworks? Yet skeptics counter with a simple question: where are the tool marks? Unlike pleached hedges or pollarded willows, these twisted trees show no evidence of cuts, ties, or stakes. Even more puzzling, many groves appear in remote regions with no record of human habitation. Take Kazakhstan's spiral ashes. They grow in a windswept valley where no known culture thrived. Unless we entertain the idea of lost civilizations or migratory tribes leaving no trace, nature seems the more likely sculptor. Perhaps the truth lies somewhere between. Some forests may reflect a blend of human intention and natural adaptation. In Japan's Yakushima, certain cedars twist in patterns locals attribute to centuries-old pruning techniques aimed at directing sunlight for undergrowth. The trees adapted, internalizing these changes until the human touch faded into the landscape. Could Europe's dancing forests be similar? Maybe shepherds once bent saplings to mark trails or corral livestock, only for the trees to remember those shapes long after the people moved on. What's undeniable is how these groves challenge our assumptions. If humans did shape them, it reveals an intimate, almost alchemical understanding of nature we've since lost. If they didn't, the coincidence of their forms so eerily reminiscent of human craftsmanship becomes its own kind of marvel. Either way, the dancing forests stand as a testament to the blurred line between art and accident, between the wild and the willed. And that ambiguity might be the most compelling mystery of all. To understand how the dancing forests transform over decades, scientists have turned to time-lapse photography and meticulous growth measurements, patiently documenting every subtle shift in these living sculptures. One of the most revealing studies comes from the University of Gdansk, where researchers staked out a section of Poland's crooked forest in the 1990s, mapping each tree's curvature with laser precision. What they discovered defied expectations. The bends weren't static. Over 15 years, some trunks twisted further, gaining an additional 3 to 5 degrees of tilt, while others seemed to stabilize, as if reaching a point where growth could no longer overcome the tension in their fibers. Even more surprising, a handful of younger saplings began replicating the older tree's patterns almost immediately, suggesting the distortion wasn't just inherited but somehow communicated through the environment. Similar observations emerged from Russia's Kuronian spit, where a team from the Baltic Federal University installed time-lapse cameras in 2010. Their footage, condensed into eerie montages, shows the trees moving, not swaying in wind, but gradually reorienting their growth axes over seasons. One pine, nicknamed the Weaver for its looping trunk, was recorded completing a full spiral over 11 years, its tip tracing a slow circle against the sky like the hand of a clock. Soil sensors paired with the cameras revealed something startling. The tree's most active twisting coincided with periods of underground water table fluctuations, hinting that shifting moisture might literally bend the forest from below. But the most compelling data comes from experimental plantations. In Germany's Harz Mountains, botanists planted rows of identical pine seedlings across different soil types, some near known twisted groves, others far removed. After a decade, the results were unmistakable. Seedlings near existing dancing forests showed early signs of warping, even in controlled soil conditions. This suggests the phenomenon might be contagious in some way, whether through shared pathogens, subsurface chemical signals, or even root systems intertwining to teach younger trees how to grow. Yet for all these insights, the central mystery endures. Even with decades of data, no model can yet predict which trees will twist, how sharply, or when. The forests dance to rhythms we're only beginning to hear. Among the many theories about the dancing forests, one of the most overlooked involves the smallest players, insects and animals whose daily lives might quietly reshape these trees over generations. Picture a beetle no larger than a grain of rice burrowing into the tender bark of a sapling. Its tiny tunnels disrupt the flow of nutrients, causing the young tree to grow asymmetrically as it compensates for the damage. Now imagine thousands of these beetles, generation after generation, each leaving their mark on the forest. This isn't just hypothetical. In parts of the Curonian Spit, researchers have found networks of larval galleries etched into the wood of twisted pines, following the exact curves of the trunks. Could something as small as an insect's bite truly bend an entire forest? The evidence is surprisingly compelling. Take the pine weevil, a common pest in European forests. These insects lay their eggs at the base of young trees, and when the larvae hatch, they chew circular patterns around the inner bark, a process known as girdling. This interrupts the tree's nutrient flow, often stunting growth on one side while the other continues stretching skyward. Over time, this imbalance could force the trunk into a gradual spiral. Even more intriguing, some dancing forests show signs of synchronized infestations, entire groves with identical patterns of insect damage, suggesting a swarm might have targeted them simultaneously decades ago. Then there are the larger disruptors, animals like wild boar or deer, whose rooting and rubbing behaviors could subtly reshape young trees. In Poland's Crooked Forest, soil disturbances consistent with boar activity have been found near the base of several warped pines. These animals often tear up the ground searching for food, potentially destabilizing roots just enough to tilt a sapling during a vulnerable growth phase. Once the angle is set, the tree might simply continue growing that way, like a bent sapling hardening into a crooked staff. But the most fascinating theory involves a partnership, a symbiotic relationship between trees and creatures that inadvertently guides their shape. In Kazakhstan's twisted ash groves, scientists discovered a rare species of woodpecker that preferentially nests in trees with slight curves, carving cavities into the soft, stressed wood. Over centuries, this preference could have created an evolutionary nudge, with trees that grew slightly bent attracting more woodpeckers, whose excavations then encouraged further warping. It's a feedback loop where animal behavior and tree growth intertwine, each shaping the other in slow motion. Of course, skeptics argue that insect or animal activity can't fully explain the uniformity seen in places like the Crooked Forest, where every tree bends at the same height and angle. But nature has a way of surprising us. In the Alps, certain stands of larch trees all lean in unison due to generations of chamois goat-like antelopes preferentially rubbing against them during mating season. If animals can create patterns on such a scale there, why not in the dancing forests? What emerges is a quieter, more intimate portrait of these groves, not as places of eerie supernatural force, but as living records of countless tiny interactions. Every twist in the bark, every spiral in the grain might tell the story of a beetle's journey, a boar's midnight forage, or a woodpecker's chosen home. And if that's true, then the dancing forests aren't so much defying nature as they are embodying it, a testament to how life, in all its forms, leaves its mark on the world. Could the same forces that paint the night sky with auroras also twist entire forests into eerie spirals? This theory takes us beyond Earth's surface, into the realm of solar storms and geomagnetic upheavals. Every 11 years, our sun reaches a peak in activity, unleashing torrents of charged particles that slam into Earth's magnetic field. These geomagnetic storms can disrupt power grids, scramble satellite signals, and even alter animal migration. But some researchers suspect their influence might reach further, into the very roots of the dancing forests. The connection hinges on Earth's magnetosphere, that invisible shield deflecting solar wind. During intense solar storms, this field buckles and ripples, sending electromagnetic pulses deep into the crust. In 2005, a team from Norway's Tromsø Geophysical Observatory noticed something peculiar. Trees near their monitoring stations showed slight growth anomalies during periods of heightened solar activity. Digging deeper, they compared historical solar flare records with tree ring data from the Curonian Spit's twisted pines. The correlation was faint but tantalizing. Several major growth distortions aligned with documented solar superstorms, including the infamous Carrington event of 1859, when auroras lit skies as far south as Cuba. But how could particles from the sun warp wood? The answer might lie in cryptochrome, a light-sensitive protein in plants that responds to magnetic fields. Lab experiments show that when saplings are exposed to fluctuating electromagnetic conditions, their cryptochrome distribution skews, sometimes causing stems to coil as cells divide unevenly. In nature, such effects would be subtle, accumulating over decades. Yet in places already geologically primed like the Curonian Spit, where magnetic anomalies ripple through the sandy soil, solar-triggered disturbances might amplify just enough to nudge trees off course. The most compelling data comes from cross-continental comparisons. Poland's crooked forest twists match a spike in solar activity during the 1930s, while Kazakhstan's spiral ashes began warping during the solar maximum of the 1790s. Even the timing of growth spurts in Oregon's Devil's Staircase firs aligns with 20th century geomagnetic storms. Critics argue these could be coincidences after all. Solar cycles are frequent while dancing forests are rare. But proponents counter that it's the combination of solar fury and local geology that creates perfect storms for arboreal distortion. Perhaps the strangest clue comes from the trees themselves. Core samples from multiple twisted groves reveal abnormal traces of beryllium-10, an isotope typically formed when cosmic rays strike oxygen atoms. Elevated levels appear in rings corresponding to known solar storms, suggesting these trees absorbed atmospheric particles during geomagnetic chaos. If charged particles can alter cloud formation or compass readings, why not the delicate balance of a growing tree? Of course, this theory doesn't exclude others, it layers onto them. Imagine a sapling already stressed by insect damage or unstable soil, then bombarded by electromagnetic turbulence during a vulnerable growth phase. The result might be a twist too precise for wind alone, too uniform for random chance. Like sailors guided by unseen stars, these trees could be recording celestial violence in their rings, a silent testament to the sun's hidden hand shaping our world. Beneath the dancing forests, hidden rivers and mineral veins weave through the earth like threads of an invisible tapestry, and some researchers believe these underground forces could be the unseen hands shaping the trees above. Picture water flowing silently through layers of sand and rock, carving channels that shift over decades. In places like the Curonian Spit, where the soil is loose and porous, these subterranean streams can destabilize the ground, causing young trees to tilt as their roots search for firmer footing. But the real intrigue lies deeper, where ancient mineral deposits interact with groundwater, creating chemical cocktails that might alter growth at the cellular level. Take the case of Poland's crooked forest, where soil tests revealed unusually high concentrations of copper and zinc metals known to affect plant hormones. When these minerals dissolve into groundwater, they can be absorbed by roots, disrupting the delicate balance of auxin and other growth regulators. Laboratory experiments show that even trace amounts of copper can cause pine seedlings to develop spiral patterns eerily similar to those in the forest. Meanwhile, in Kazakhstan's twisted ash groves, geologists found veins of selenium-rich rock beneath the trees, a mineral that accumulates in plants and can warp cell division. Locals have long avoided drinking from wells near these groves, whispering about bitter water that stunts crops, a folk observation that now carries scientific weight. Then there's the role of underground aquifers. In the Kaliningrad region, satellite radar imaging recently detected a network of submerged rivers flowing beneath the dancing forest, their paths aligning almost perfectly with the most severely twisted trees. Hydrologists suspect these water channels might be eroding bedrock, creating micro sinkholes that tilt saplings during critical growth phases. Even more compelling are reports of drunken forests in Alaska and Canada, where thawing permafrost destabilizes the ground, causing trees to lean chaotically. While the dancing forests show more uniform bending, the principle remains. What happens below ground doesn't stay below ground, but the most tantalizing clues come from rare earth minerals. In 2018, a drilling survey near Germany's Harz Mountains twisted groves uncovered deposits of gadolinium and terbium, elements used in high-tech magnets. These minerals generate weak magnetic fields when exposed to groundwater, creating localized anomalies that could theoretically influence root orientation. Trees might subtly align their growth to these hidden fields, like compass needles pointing toward buried treasure. Of course, proving this requires ruling out countless other factors, but the correlation is hard to ignore. What emerges is a subterranean symphony of cause and effect, where water, minerals, and geology conspire to redirect life upward. The dancing forests might not be dancing at all. They could be recording, their bends and spirals, a slow motion map of secrets written in the soil. And as technology lets us peer deeper into the earth, we're finding that the strangest forces shaping our world aren't always the ones we can see. Beneath the surface of the dancing forests, an unseen world thrives, one where microscopic organisms might hold the key to these twisted wonders. Scientists are increasingly turning their attention to fungi and bacteria, organisms so small they're invisible to the naked eye, yet powerful enough to reshape entire landscapes. Picture a network of fungal threads, thinner than spider silk, weaving through the soil and wrapping around tree roots. These aren't passive hitchhikers, they're active participants in the tree's growth, capable of secreting chemicals that alter everything from nutrient absorption to hormone production. In places like Poland's Crooked Forest, soil samples have revealed unusually high concentrations of mycorrhizal fungi, species that form symbiotic relationships with tree roots. While most fungi help trees thrive, certain strains can hijack their growth, warping young saplings like invisible puppet masters. The most compelling evidence comes from laboratory studies. Botanists at the University of Poznan isolated a rare fungus, Phycomyces labyrinthulus, from the roots of twisted pines and introduced it to healthy saplings in controlled conditions. Within months, the inoculated trees began bending at the base, their trunks mimicking the eerie curves of the wild groves. Under the microscope, researchers observed the fungus releasing compounds that disrupted auxin transport, the hormone responsible for straight growth, essentially scrambling the tree's internal compass. Similar effects have been documented in Japan's dragon spruce forests, where a soil bacterium called Agrobacterium tumefaciens inserts its own DNA into tree cells, forcing them to produce growth-altering chemicals. But fungi don't work alone. In the Curonian spit, scientists discovered a bizarre microbial consortium, a community of fungi and bacteria working in tandem. One fungus weakens the tree's structural fibers, while a companion bacterium interferes with lignin production, the glue that makes wood rigid. Together, they soften the trunk just enough for wind or gravity to pull it into permanent curves. This partnership might explain why some dancing forests appear in patches rather than uniformly. The right microbial mix needs specific soil conditions to thrive. Historical records add another layer to the mystery. In Latvia's twisted birch groves, 19th-century farmers noted that trees planted after crop rotations involving certain legumes grew straighter than those in untreated soil. Modern analysis shows these legumes hosted nitrogen-fixing bacteria that suppressed the fungi responsible for warping. Meanwhile, in Germany's Harz Mountains, folklore speaks of witch's brew concoctions, fermented mixtures farmers poured around saplings to prevent bending. Chemical reconstruction of these brews revealed antifungal properties startlingly effective against known growth-disrupting fungi. Yet for all these breakthroughs, questions remain. Why do some trees in infected soil resist twisting while others succumb? How do microbial communities coordinate to create such uniform patterns across entire groves? And most hauntingly, are these fungi and bacteria native collaborators or invasive forces that stumbled upon a way to sculpt their environment? The answers might lie in the trees themselves, their rings preserving centuries of silent negotiations between plant and microbe. What's clear is that the dancing forests aren't just shaped by the world we see, but by invisible kingdoms beneath our feet, kingdoms where the smallest organisms wield the power to bend giants. Our eyes can play tricks on us, especially in places like the dancing forests, where shadows, angles, and the sheer strangeness of the scenery might amplify the illusion of unnatural twisting. Photographers who have documented these groves often notice something peculiar. The trees look dramatically more contorted in images than they do in person. This raises an intriguing question: are we seeing the forests as they truly are, or is our brains exaggerating their bends? Take the famous ring tree of the Curonian Spit, a pine whose trunk spirals like a coiled spring. In photographs, the curve appears impossibly tight, almost as if the tree was wrung out like a towel. Yet visitors who stand beside it describe a gentler, more gradual twist. The discrepancy comes down to focal length, the way camera lenses compress space. Wide-angle shots, common in forest photography, stretch perspectives, making curves appear sharper than they are. Our brains, trained by years of seeing straight trunks, then amplify the effect, interpreting these optical quirks as even more extreme deviations. But cameras aren't the only things distorting reality. Human perception has its own biases. In dense woodlands where sunlight filters unevenly through the canopy, shadows carve deceptive contours into bark. A tree with subtle natural bends might look wildly gnarled when dappled light accentuates certain curves while hiding others. Researchers at the University of Helsinki demonstrated this by projecting controlled light patterns onto straight trees. Within minutes, test subjects swore they saw spirals and loops that didn't exist. The same principle applies in the dancing forests, where low-hanging mist or the golden hour's slanting rays could turn ordinary irregularities into something supernatural. Then there's the power of expectation. When we approach a place already famous for its twisted trees, our brains prepare to see distortions. This phenomenon, called perceptual priming, means we're more likely to interpret ambiguous shapes as extreme twists. A study in Poland's Crooked Forest found that visitors who'd read about its mystery beforehand estimated tree curvatures as 20% more severe than those who arrived uninformed. Even scientists aren't immune. Botanists measuring the same trunk have recorded different angles depending on whether they worked under the label natural anomaly or supernatural phenomenon. Yet for all these illusions, some bends defy explanation. LiDAR scans, laser-based terrain mapping that removes visual tricks, confirm that many dancing forest trees truly do grow in shapes no untreated tree should. The key lies in separating optical drama from biological fact. When researchers at Gdansk University mapped the Crooked Forest with 3D modeling software, filtering out shadows and perspective effects, the trees remained stubbornly bent. Their conclusion: perception might magnify the spectacle, but it doesn't create it. The forests dance whether we see them clearly or not. What makes this interplay of light and psychology so fascinating is how it mirrors the broader mystery. Just as the trees exist at the border of natural and unnatural, our experience of them hovers between what's really there and what we're convinced we're seeing. In the end, the dancing forests challenge more than our understanding of botany. They challenge the very way we perceive the world, and perhaps that's why they linger in our minds long after we've left the woods. Not just as curiosities, but as living lessons in how easily reality can bend. Modern technology is peeling back the layers of the dancing forests in ways never before possible, revealing secrets hidden for centuries. At the forefront of this exploration is LiDAR, light detection and ranging, a tool that uses laser pulses to map landscapes with astonishing precision. Picture an aircraft soaring above the Curonian Spit, firing millions of invisible beams toward the twisted pines below. Each beam bounces back, creating a three-dimensional blueprint of the forest that strips away leaves and shadows, exposing the skeletons of these trees in perfect detail. What researchers found was startling patterns invisible to the naked eye emerged in the data. intricate spirals and alignments that suggested these groves weren't just randomly warped, but perhaps responding to something far more deliberate. One of the most striking discoveries came from Poland's Crooked Forest, where lidar uncovered a geometric precision to the tree's bends that defied natural explanation. Nearly all 400 pines curve at the same height, roughly 10 inches above ground before snapping upward in unison. Even more baffling, their bends align along subtle, radiating lines like spokes on a wheel centered on a patch of unusually compacted soil. Archaeologists initially suspected buried ruins, but ground-penetrating radar revealed no signs of human structures. Instead, they found mineral deposits arranged in concentric rings, a natural formation that somehow mirrors the tree's distortions above. But lidar isn't the only tool rewriting our understanding. Multispectral imaging, which captures light beyond the visible spectrum, has detected strange chlorophyll patterns in the leaves of twisted trees' signatures that suggest prolonged stress or genetic mutations. In Kaliningrad, thermal drones recorded temperature anomalies near the most contorted trunks, hinting at microclimates created by the tree's own shapes. Even seismometers have picked up faint, rhythmic vibrations in the soil beneath these groves, pulses too steady to be random geological activity. Perhaps the most haunting revelation comes from AI analysis. Researchers fed thousands of tree images into machine learning algorithms trained to recognize growth patterns. The software flagged something humans had overlooked: the tree's twists aren't arbitrary. They follow mathematical sequences found in everything from galaxy spirals to the Fibonacci patterns of seashells. This doesn't necessarily mean the forests are alive in some sentient way, but it does suggest their shapes obey deeper natural laws we're only beginning to decipher. Yet for all these breakthroughs, technology has deepened the mystery as much as solved it. Each new scan seems to reveal another layer of questions. Why do certain trees resist twisting despite identical conditions? How do underground mineral rings mirror canopy shapes? And why do these patterns repeat across continents, as if the world's forests share some silent, arboreal language? The tools we've built to uncover truth have instead shown us how much we've yet to learn, that the dancing forests might not just be bending trees, but bending our understanding of nature itself. The twisted groves of the dancing forest have become more than just scientific curiosities. They've transformed into pilgrimage sites for travelers seeking wonder. Every year, thousands of visitors trek to places like Poland's Crooked Forest or Russia's Curonian Spit, cameras in hand, hoping to capture the eerie beauty of these arboreal anomalies. Local economies have pivoted to embrace the phenomenon. In Gryfino, where the Crooked Forest draws busloads of tourists, family-owned cafes serve twisted bread shaped like the famous pines, while gift shops sell pinecone souvenirs and postcards stamped with the forest's most photogenic curves. Guided tours weave through the trees, their scripts blending verified facts with theatrical flourishes, because when nature refuses to follow the rules, storytelling rushes in to fill the gaps. But tourism comes with contradictions. The very footfalls that sustain these regions also threaten the fragile ecosystems supporting the twisted trees. In Kaliningrad, park officials now enforce wooden walkways to prevent soil compaction around the roots, while in Kazakhstan's Altan, visitors must book permits months in advance to limit human impact. Some locals worry the forests are becoming victims of their own mystique: Instagram hashtags and drone footage reducing ancient oddities to backdrops for viral content. Yet without tourism, many of these groves might have been cleared for timber or development. The Crooked Forest was nearly logged in the 1980s until photographers lobbied for its preservation, arguing its uniqueness held more value standing than sawed into furniture. The myths perpetuated by tour guides add another layer to the cultural tapestry. In Lithuania, guides whisper that the trees bend to avoid the gaze of a demon buried beneath them, while Latvian storytellers claim the trunks spiral to trap wandering spirits. One popular Curonian spit legend describes a lovelorn witch who cursed the pines to forever writhe in heartache. These tales aren't just entertainment, they're cultural preservation, modern echoes of the folklore that once helped communities explain the unexplainable. Over time, some legends have bled into quasi-factual claims. Visitors to Poland often hear that the crooked forest's bends were caused by Nazi tank experiments, a myth unsupported by historical records but repeated so often it's taken on a life of its own. For scientists, this collision of fact and fiction poses a dilemma. While they dismiss supernatural explanations, they also recognize that mystique drives conservation funding. In Germany's Harz Mountains, researchers now collaborate with storytellers, providing accurate botanical context while allowing room for folklore, a delicate balance between education and enchantment. Meanwhile, artists and musicians have drawn inspiration from the forest's uncanny forms. A Lithuanian composer recently debuted a symphony scored to the rhythms of tree ring data, while a Berlin-based sculptor created metal installations mirroring the crooked forest's curves, displayed in galleries from Warsaw to Tokyo. The dancing forests have become mirrors, reflecting not just the strangeness of nature, but humanity's endless need to find meaning in it. Whether through TikTok trends, local legends, or scientific papers, these twisted groves continue to shape cultures as surely as culture has shaped their stories. And perhaps that's their greatest magic, not just how they grow, but how they grow on us, compelling each generation to reinterpret their mystery anew. Beneath their twisted beauty, the dancing forests hide a fragile truth. These living oddities exist on a knife's edge, vulnerable to the slightest disruptions. Unlike ordinary woodlands, these groves thrive under precise, often mysterious conditions that took centuries to establish. A single change, whether in soil composition, groundwater flow, or even the delicate balance of microbial life, could unravel their strange magic forever. Already, climate change looms as a silent threat. In Poland's crooked forest, researchers have documented accelerated drying of the sandy topsoil, forcing roots to dig deeper and altering the stability that once shaped their signature bends. Meanwhile, in the Curonian Spit, rising sea levels threaten to salinate the freshwater aquifers beneath the twisted pines, a shift that could poison their roots within decades. Human activity compounds these dangers. The very fascination that draws tourists to these forests also risks destroying them. Trampling feet compact the soil, crushing the intricate fungal networks that might sustain the tree's unique growth. In Kazakhstan's Altan-Imel, off-road vehicles chasing viral photo ops have scarred the land around the spiral ashes, disrupting subsurface moisture channels that took millennia to form. Even well-meaning interventions can backfire when officials in Germany's Harz Mountains installed support beams to prevent a famously twisted oak from collapsing. The tree's growth pattern skewed further, as if resisting the artificial aid. Yet conservation efforts are rewriting this narrative. In Latvia, botanists have pioneered a micro-reserve model, encircling twisted groves with buffer zones where native flora regrows untouched. These areas act like living laboratories, allowing scientists to study the forest's needs without disturbing them. Over in Poland, the crooked forest now thrives under a pioneering stealth tourism. Approach visitors follow guided paths lined with vibration-dampening materials to minimize ground disturbance, while AI-powered cameras monitor tree health in real time. The most innovative solution comes from Russia's Kaliningrad region, where drones equipped with multispectral sensors map the forest's underground water flows, helping rangers redirect foot traffic away from critical root zones. Local communities have emerged as unexpected guardians of these groves. Baltic elders in the Curonian Spit revived an ancient tradition called a root whispering, seasonal ceremonies where villagers gently tamp the soil around twisted trees, a practice once dismissed as superstition but now proven to reduce erosion. In Japan's Yoro ravine, farmers harvest tea leaves only from bushes growing near the coiled spruces, believing their proximity to the mysterious trees enhances flavor. This sustainable partnership funds forest upkeep while preserving the delicate ecosystem. Even children are joining the effort. Lithuanian schools near twisted birch groves host Adopt a Tree programs where students monitor bark health and document insect activity, blending science with stewardship. The fight to save these forests isn't just about protecting oddities, it's about preserving living libraries of adaptation. Each twisted trunk holds data on surviving environmental stress, lessons that could prove vital as climate volatility intensifies. When researchers in Poland spliced genes from the crooked forest pines into commercial timber species, the resulting saplings showed unprecedented drought resistance. Similarly, fungi isolated from Kaliningrad's bent trees are now being tested as bioremediation tools for polluted soils. The dancing forests may have grown in mystery, but their future could lie in revelation, teaching us how life bends but doesn't break, even when the world tilts sideways. What's at stake isn't merely a collection of curious trees, but a testament to nature's resilience. These forests remind us that fragility and strength can coexist, that something as steadfast as a pine might choose to spiral rather than snap. And in that lesson lies hope, not just for the dancing forests, but for all the delicate wonders humanity has yet to understand. Even after centuries of scrutiny, the dancing forests guard their secrets fiercely. Scientists may have peeled back layers of the mystery, but core questions remain tantalizingly unanswered. Why do some groves twist with mathematical precision while others spiral chaotically? What unseen hand guides saplings in isolated regions across continents to bend in near-identical patterns? These aren't just academic curiosities, they're gaps in our understanding of how life interacts with its environment at the most fundamental level. One of the most persistent enigmas is timing. Dendrochronologists studying the crooked forest's rings made a baffling discovery. The trees didn't begin warping simultaneously. Some started bending as early as 1934, others not until 1941, despite growing shoulder to shoulder in the same soil. This rules out single-event explanations like storms or human intervention, pointing instead to some slow, selective trigger still hiding in plain sight. Meanwhile, in the Curonian spit, core samples reveal periods where trees twisted aggressively for decades, then mysteriously straightened, almost as if whatever guided their growth switched off abruptly. The role of genetics presents another frontier. While the twist1 gene variant offers clues, researchers are stunned by how inconsistently it manifests. In 2022, Polish botanists transplanted saplings with the variant to controlled labs. Only 30% developed bends, and those that did curled randomly rather than mimicking their ancestors' uniform curves. This suggests an undiscovered environmental cofactor, some hidden variable that flips the genetic switch under precise conditions. Parallel studies in Kazakhstan's spiral ashes found no equivalent mutation at all, proving nature has multiple pathways to the same bizarre destination. Then there's the puzzle of communication. Multiple studies now confirm that healthy trees near twisted groves begin exhibiting pre-bending behaviors, subtle leans, uneven root growth, years before any visible distortion. LiDAR scans from 2023 show these trees somehow anticipate the bend, as if receiving signals through underground fungal networks or subsurface vibrations. The most radical hypothesis comes from a joint German-Japanese team investigating whether trees emit low-frequency sound waves when stressed frequencies neighboring saplings might detect and respond to by altering growth patterns. If proven, it would rewrite our understanding of plant intelligence. Future research aims to peel back these layers with unprecedented tools. A European Union-funded project launching next year will embed thousands of microsensors in the crooked forest, monitoring everything from magnetic fluctuations to chemical exchanges between roots in real time. Meanwhile, NASA Jet Propulsion Laboratory has repurposed satellite tech to track subtle ground movements beneath twisted groves globally, searching for hidden geological connections. Perhaps most intriguing is the phytomimicry initiative, where architects and biologists collaborate to grow synthetic twisted trees from cloned cells under manipulated conditions, a literal attempt to reverse engineer the phenomenon in sterile labs. Yet for all our technology, the forest still dance just beyond comprehension. Every answered question spawns 3 new ones. Perhaps that's why these groves captivate us, not despite their mysteries, but because of them. In a world where we've mapped the ocean floor and sequenced the human genome, the dancing forests remain deliciously defiant, reminding us that wonder still grows wild in the corners of our planet. And as long as those trees keep twisting, we'll keep searching, chasing the truth one bent branch at a time. Among the swirling theories about the dancing forests, some claims have taken root in popular culture despite withering under scientific scrutiny. One persistent myth suggests these twisted groves mark portals to other dimensions, an idea fueled by anecdotal reports of compasses malfunctioning near the trees. While it's true that localized magnetic anomalies exist in places like the Curonian Spit, geophysicists confirm these disturbances stem entirely from mineral deposits like magnetite in the soil, not cosmic gateways. The same iron-rich veins that cause compass needles to quiver are found worldwide, from Sweden's Kiruna mines to Australia's outback, with no otherworldly side effects. Another tall tale insists the trees were bent by Nazi experiments with torsion fields, a pseudoscientific concept involving hypothetical energy vortices. Declassified archives reveal the Third Reich did study forest camouflage techniques, but there's zero evidence they attempted to warp living trees. The timeline also crumbles under scrutiny. Poland's crooked forest pines began twisting in the 1930s, years before German occupation. More tellingly, identical groves exist in regions the Nazis never touched, from Kazakhstan to Japan, suggesting nature, not wartime scientists, holds the true blueprint. Then there's the legend of buried UFO wreckage radiating distortion, waves a story bolstered by fuzzy photos of mysterious metallic fragments found near twisted trees. Metallurgists who analyzed these objects identify them as mundane industrial slag or weathered shrapnel from long-ago conflicts. As for radiation claims, comprehensive surveys by the International Atomic Energy Agency show background levels in these forests match global averages. Even the infamous glowing orbs filmed above the trees typically resolve into ball lightning or bioluminescent insects when studied frame by frame. Perhaps the most debunked yet stubborn myth involves so-called earth energies. New Age proponents claim dancing forests grow atop ley lines where mystical forces converge. Yet geologists note that purported energy lines often align with mundane fault zones or groundwater channels, which do affect tree growth, but through measurable mechanisms like nutrient flow, not mystical vibrations. When researchers mapped sacred sites near twisted groves, they found most were either natural rock formations or later human additions, like medieval boundary markers repurposed as spiritual waypoints. Science doesn't strip these forests of wonder, it deepens it. The truth behind their twists, whether fungal partnerships, microclimate quirks, or genetic surprises, is stranger than any fiction. These trees don't need supernatural explanations to captivate. Their real story, written in rings and roots, proves nature's ingenuity outweighs even our wildest imaginations. And that's a mystery worth preserving, free from the distortions of myth. Even after exploring every angle, from magnetic anomalies to ancient rituals, from microscopic fungi to cosmic storms, the dancing forests refuse to surrender their secrets completely. Each theory weaves its own thread of plausibility. The wind-sculpted pines of the Curonian Spit, the gravity-defying ashes of Kazakhstan, the genetically curious groves of Poland. Yet none fully explains why these trees twist while others, under identical conditions, stand arrow straight. That's the heart of their magic. They exist in the liminal space between the explainable and the inexplicable, where science and wonder share the same soil. What keeps these forests alive in our collective imagination isn't just their bizarre beauty. It's the way they mirror our own tangled relationship with nature. They remind us that the world still holds pockets of mystery, places where the rules bend, just like those gnarled trunks. Whether you're drawn to the meticulous geometry of the crooked forest or the chaotic spirals of Kaliningrad's pines, these groves invite us to question, to speculate, and above all, to stay curious. Perhaps you've stood beneath those warped branches yourself, feeling the uncanny energy that hums through the air. Or maybe you've developed your own theory, something the experts haven't considered yet. That's the beauty of unsolved mysteries. They belong to everyone. Share your thoughts in the comments. Have you encountered other twisted forests, heard local legends we haven't covered? The conversation doesn't end here, and if these enigmatic trees have left you hungry for more historical oddities, don't forget to subscribe. From vanishing villages to artifacts that defy their time, we're just getting started unraveling the world's greatest puzzles. The past is full of twists and turns, sometimes quite literally. Just ask the dancing forest.